Thank you very much for the introduction. So, in addition to the MSc program, I'm also working part-time at the iHomeLab. It's a competence center for building intelligence at the Lucerne University of Applied Sciences and Arts. And we had already a few projects that contained speech recognition in some form, for example as a voice assistant. And as some of you may already know, Swiss German is not that easy to recognize, so we had to use often some standard German speech recognition system instead. Then we came up with the idea that in some use cases you don't really need to recognize every dialect in Switzerland. It would be enough to recognize one dialect, or here in this word, just one person. And this is the whole idea behind this project. Now we defined here some procedures, some approaches, how you could possibly define, how you could possibly adapt a model on one speaker, on a single speaker. But before I come to that, I would just talk about briefly what kind of data and model we used to train. Now, most of you are, I'm pretty sure, already familiar with some challenges of Swiss German. Have not really a standardized written form. In most cases, we want, it is desired that we have a standard German text as output of a model, of a speech recognition system. And for that, we would also need some kind of translation step. Then we have some other specialities in our language. For example, we have a tendency to merge words together. For example, bimene, hemmer, wemmer, which would translate to 2 words or even more in standard German. So to the model we use, it is a Wave2Vec2 model, which you already heard yesterday, but we used like a smaller brother of the model. It is also published by Facebook, or now Meta AI. And important to know about the model is that we use the raw audio signal as an input for the model. It contains of CNN, convolutional layers, and transformer blocks, and the model returns us a sequence of the most probable characters given the input sequence. So the model predicts characters and not words. That's another important fact that we have to see later. Now, how do we evaluate our approaches? We use word error rate simply because it's a very common metric in this area. Has also some disadvantages, which we see also later. A quick example, in this metric we simply count the number of transformation to get from the prediction to the ground truth. So we count the number of substitutions, insertions, and deletions, and divide it by the number of words in the reference. In this example, we would have to replace 3 words and insert 1 additional word to transform our prediction to the ground truth. To train the model, we also need data. We need, on the one hand, a dataset containing multiple Swiss German speakers, and on the other hand, of course, some datasets containing only audio files from 1 speaker. The datasets are mostly based on the Swiss Parliament's corpus. We've already heard of it in the last years or even yesterday. It's a dataset containing recordings and transcription of a Swiss Parliament, and the transcriptions are also in standard German. Now, how do we get the single speaker datasets? We remove in the first step the 5 speakers with the most number of samples in the original Swiss Parliament corpus, and this leaves us with dataset containing multiple speakers, or the remaining speakers, and 5 datasets containing only audio data from one speaker. In addition, we record a 6th dataset, and we limit all the single speaker datasets to 1.5 hour audio data. Now, what do we train? What do we evaluate? We have defined 3 approaches. In the first approach, we take the pre-trained model, which was trained on multiple languages, and train it and evaluate it on only 1.5 hours of Swiss German data of one speaker. In the second approach, we train the model and on a dataset containing the remaining speakers of the Swiss Parliament corpus, so multiple dialects, multiple speakers, and evaluate it on one speaker. And the third approach is just a combination, it's a concatenation of 1 or 2. These 3 approaches we perform with every one of the 6 single speaker datasets we have created. Now, the results are shown in this table. A lot of numbers, I know, but if we focus now on one speaker, one can see that we gain, the word error rate decreases with every approach. The best approach we can see here, and this is true for all speakers, is when we first train our pre-trained model on multiple Swiss German speakers, and then in a second training step, train it on the same speaker, the model it will evaluate it on. If we now have a look at the last approach, you can also see that there's quite a significant difference between the speakers. There could be, or there are probably multiple reasons for this. For example, one reason could be the similarity of the dialect of a single speaker to the majority of the data used before, in the training step before. Or another reason could be some kind of bias, for example, a gender bias. If I recall correctly, for example, speaker 207 is a woman, and the vast majority of the parliament is filled with men. But we could not fully determine the real cause of the difference and the individual improvement, so these are only assumptions that we made. In addition, we did also some further experiments. So we did evaluate every fine-tuned model that was trained on one speaker on the other 5 single speaker datasets. That has shown us that the word error rate increases slightly. So we could argue that the model indeed learns from one speaker and adapts on one speaker. We also try to increase the training dataset size of the single speakers. So instead of 1.5 hours, we used 6 hours on one speaker. That was the biggest amount that we could take from the one speaker. And we see an improvement of 2% word error rate. On the other hand, we used only a third, so half an hour instead of 1.5 hour, and the word error rate increases by 4%. So based on these findings, you could say that there is some kind of dependency between the single speakers and between the dataset used for the general Swiss German training. Now I have some kind of example prepared. For those of you who don't speak Swiss German, I'm sorry, you have to trust me here. You can see here the original label of the dataset. I'll play now the audio, corresponding audio file.
In dem Sinn erkläre ich die Session vom September als eröffnet.
Was it loud enough or? Yes. Yeah. Good. I can play it again.
In dem Sinn erkläre ich die Session vom September als eröffnet.
Now, after we heard the audio file, you could also argue that this could be a label. Because in the audio file, we hear, or at least when you're understanding Swiss German, you hear that the speaker is saying die Session vom September and not die September Session, which would also be correct. And this shows, or this displays perfectly the challenges we have in Swiss German. It's not really a one-to-one mapping between the audio and the label. So we have really to think about how do we label the data, and this can be quite complex. Now, when we look at the prediction, as expected, the pre-trained model is quite struggling with the Bernese dialect of speaker 82. The prediction of our model are somewhat good, but interesting is when we have a look at the word error rates. You see some of the word error rates are quite high for our trained models. But if we now consider instead of the original label, my interpretation, you see that the word error rate is decreasing by a factor of around 2, quite significant. To conclude, we have seen that the best approach in our case to adapt the model on such a single speaker is to first train a model on multiple Swiss German speakers and then train it on the same speaker it will be evaluated on. However, the improvement we've observed is pretty individual per speaker, and there can be multiple reasons for this. For example, as I already mentioned, a bias in the dataset used for the training. As we have seen in the example before of speaker 82, we have also the difficulty of labeling that can lead to influence the performance of a model depending on how many samples there are. And in addition, we also have found some examples containing standard German audio instead of Swiss German audio. And this could also, of course, influence the model because it was also trained in standard German data. And then if a speaker has more standard German audio samples, that could lead to better performances of one speaker. Now, as an outlook, of course, it would be very interesting to test more speakers than only 5 or 6. And in addition, also it was also interesting to check how do other models behave. Do we get similar results when using these approaches with other models? And also, as we have seen in the example, we have to carefully choose the evaluation metric. Often in the field of speech recognition, you simplify the word error rate. But in our case, since it is a character-based model, we could also have used the character error rate. But then you lose some kind of comparability between the different works and different approaches. So it's kind of a trade-off. But also a challenge with Swiss German. Thank you very much for your attention.
Thank you very much. Are there any questions? Tanya.
Maybe to start with this, first a clarification question. If you can come back to the slide when you are deciding which speakers you use for pooled Swiss data. Mm-hmm. So are you using only the remaining of your data, so not the 5 top speakers?
No, the 5 speakers are separated
And then you use the rest.
The
and then you
rest.
only test on one
Exactly,
of the 5.
exactly, yeah.
So one suggestion would be you might want to have also in this fine-tuning speakers with a lot of data. So maybe not just the one that you are testing, but all the others. That might help.
Yeah, that's true. Yeah, we were also quite limited with the single speaker adaptation because the 1.5 hours were given because the speaker with the 5th most amount of samples has around 1.5 hours. So we would like to have experimented more with, for example, more, but this was.
So this intuition comes from some other results, where more of the same in fine-tuning somehow helps, even if it's not what you're testing, but something else, but more of the same is good.
Yeah.
Maybe just a try.
Thank you.
Other questions? So then I have a question. So it's actually not astonishing that the combined fine-tuning wins the battle. But have you tried to make kind of a learning curve with the speaker with the most hours of recording so that you can see what's the influence on the single speaker corpus fine-tuning? I mean that you take half an hour, 1 hour, 1.5 hours, up to 6 hours and try to find something, how the learning behaves.
Yeah, no, not directly. We did only some few experiments given the scope and the time frame of the project. This was unfortunately not possible.
And how did you split the single speaker corpus into train and test set?
I did some random splitting and train test split 80-20. So I used 80% for training and 20% for testing evaluation.
And what about your external speaker? Is that data available?
Yeah, it's actually, I recorded samples based on the Voxforge speech corpora with my voice because it was interesting for me. And it's only, well, actually I wanted to record more, but I stopped at 1.5 hours because it was around nearly 900 samples, and yeah, it's just a recording of 1.5 hours of my voice reading some samples.
And what's your native dialect?
Actually, it's not pretty clear because where I grew up, it's like I grew up in a part of Lucerne. It's called Entlebuch, and we're between.
We are missing speakers from Entlebuch.
It's actually some kind of merge between Bernese and Lucerne dialect. So again, another funny unofficial dialect.
Okay, are there any other questions?
Yeah.
Yeah? Okay, Larissa.
What's the dialect distribution? So what dialects do your single speakers have?
Well, the single speaker are separated from the Swiss Parliament's corpus.
So it's Bern.
So it's a majority of Bernese dialect, yeah. It's Bern.
Yes, please.
Could you comment a bit on the pre-trained models for weak signals? You used the weak to vector for German. What other models or for English models even?
Yeah, generally on English you have a lot of different models and approaches you can already use, but already in German it's quite sometimes difficult to get already pre-trained models. And the one I used, the Web2Vec, is a model that was trained originally on 53 languages, and in a second step trained on more additional German data. And it has also been state of the art on German speech recognition, although it is technically a multilingual model.
Yeah, thanks.
Tanya?
Perhaps to come back to this problem of evaluation. So when you said, there is this one ground truth, but there could be another. So, is there anything that one can do about that?
Yes. So actually, we have a new project to develop a new metric. Well, thank you very much. You have proved that word error rate is not an appropriate metric.
You said you wanted to maybe discuss a bit more on that.
Yeah.
Yeah.
You have proved, and even character error rate would not help.
Yeah, it could be better for this model, but still not perfect, and still with the same problems.
And the same is with blue. Blue is also not really helpful because in general we only have one ground truth, which may be wrong even, and therefore we try to develop a new metric for this speech translation task.
But I think the question was in a different direction. I mean, everyone wants to develop a new metric, but the question was more, how do we deal with erroneous ground truth annotations? Right? Because this is a real problem usually, that the annotations are not correct, or the speakers don't speak what is written in the text.
Yeah.
So well, could one maybe have something more flexible?
Yeah, well, technically, both labels I showed are correct.
Are correct.
So, if one could argue that Session from September, so the three Swiss German words, that's more a direct interpretation of the audio signal, but that the word September Session is more likely to be a formal standard German word for it.
So that's
so you would likely have to, for every audio signal, you would have to have multiple labels that would be correct for the evaluation.
Several correct transcriptions.
Flexible measure. Yeah, but this is, you see here, I think the fun thing is what is correct, because here, if you want to target exactly the formal style, then there is only one correct.
No, but when you take blue, for example, you can have several correct transcriptions. So an idea could be to create from one ground truth several possible.
With paraphrasing.
Yes, and with semantic similarities and stuff like that. So you can create a whole bunch of more or less correct transcriptions.
Yeah, and more interesting is it. This was just one example, but when I was recording myself, I had also some standard German text which contained past simple. And now, how do you pronounce past simple in Swiss German? You have to completely reconstruct the sentence in a way so that you can speak it in your dialect. And this is a whole other challenge, leading to the same problem.
Thanks. It's very interesting.
Okay, then I think we can change to the next speaker.